You know, all around us, in these huge factories, in our power grid, there are these hidden workhorses. They're silent switches, but they handle incredible amounts of power. They are, without a doubt, the unsung heroes of automation. And today, we're going to pull back the curtain and see what makes them so absolutely essential.
I mean, seriously, think about it for a second. You can't just walk up and use a regular light switch to fire up a giant industrial crane, right? Or a pump that serves an entire city. The amount of electricity we're talking about, it's just not practical. And frankly, it's way too dangerous to control by hand. So how do we do it? How do we boss around that much power safely and from a distance?
Well, the answer is with one of these. This is a contactor. And just looking at this lineup, you can see the incredible range they come in. Some are small enough to fit in the palm of your hand, while others are as big as a microwave. And each one is built for a very specific, heavy-duty job.
So here's what we're going to break down in this explainer. We'll start with what a contactor actually is. Then we'll peek inside to see how it works. We'll check out all the different types, see where they're used out in the wild, and finally, really understand why they're basically the muscles of all modern automation.
All right, let's jump right in with the basics. What in the world is a contactor? Well, at its core, it's a special kind of switch. You can think of it as a heavy-duty version of something you might have heard of before. So the textbook definition calls it an electromagnetic switch. But the real magic is in the contrast, right? It's built to handle these massive, high-current circuits, but, and this is the key, it's controlled by a tiny, low-power signal. That's the secret sauce. That's what makes it so powerful and so safe. This slide really helps make sense of where it fits in. Think of it like this. A relay is for logic. It's the brains. A circuit breaker is for safety. It's the shield, the emergency stop. But the contactor, it's all about power. It's the muscle. It's the everyday on-off switch for the big stuff, designed to work over and over and over again, not just for emergencies.
And this quote just nails it. If you only remember one thing, make it this. A contactor is really just a relay that's been seriously beefed up to handle the big leagues, to switch some serious power. Okay, so we know what it is, but how does this little bit of electrical magic actually happen? Let's take a look inside the box and see what's going on under the hood.
So inside every single one of these, you're going to find three main parts. You've got the coil. That's where our tiny control signal goes. You've got the main terminals. That's where the heavy-duty power flows through. And then you have the contact housing, which basically keeps it all safe and sound. And the process is just so beautifully simple. First, that small control signal gets sent to the coil. When that happens, the coil energizes and creates a magnetic field. That magnetic force then yanks a heavy internal switch shut, connecting the main contacts. And bam! Just like that, the high-power circuit is complete, and some massive motor roars to life. It's a tiny whisper of a signal controlling a tidal wave of electricity. Now, as you can probably guess, the contactor you'd use for a little pump is going to be totally different from one inside a locomotive. They are definitely not one size fits all. In fact, they're highly specialized for whatever job they need to do.
I mean, just look at a manufacturer's lineup, and the difference is pretty obvious. On one end, you've got these mini-type contactors for smaller jobs. But as you move across to the normal type, they get physically bigger and tougher, built to handle much, much heavier industrial loads. That size is a direct visual clue for the kind of power it's designed to tame.
And it's not just about size. They vary in a bunch of other really important ways. The control coil can be designed for AC or DC voltage. They come with different numbers of poles for different types of circuits. A lot of them even have these small auxiliary contacts that send a little, "Hey, I'm on," signal back to the main computer. And maybe most importantly, they're all classified by strict industry standards, like NEMA or IEC, that guarantee they can handle exactly the right kind of load. This table really helps put some real numbers on it. A little 9-amp contactor? Perfect for a 4-kilowatt pump. But let's say you need to run a big industrial fan. You're going to step up to a 38-amp model. And for the really heavy machinery, you might need a 100-amp contactor that can switch 45 kilowatts of power. The takeaway is simple. You have to match the contactor to the job.
Okay, so we've got the what and the how down. But where are these things actually being used? Well, the short answer is pretty much everywhere that serious power is being used in industry.
I mean, the list is huge. We're talking about the robots on assembly lines, the massive pumps and water treatment plants, the giant lighting rigs in stadiums, the conveyor belts in every warehouse. Heck, even the engines in diesel locomotives rely on them. They are the invisible but absolutely essential gatekeepers for industrial power. And if you just glance at a manufacturer's catalog page, wow, you see exactly how specialized they can get. There are models for AC, for DC, for making motors run in reverse, for switching capacitors. There's a contactor that's been designed and optimized for almost any industrial task you can dream up. And this brings us to our final and maybe the most important point. It's about the contactor's role in the entire system of automation. And really, it all comes down to connecting the brains and the brawn. Honestly, this is the best way to think about it. Modern automation runs on low-power brains, computers, PLCs, all that smart stuff. But the actual work gets done by high-power brawn, the giant motors, the heaters, the pumps. And the contactors, they are that crucial link. They're the translators, they're the interpreters that let the delicate, low-voltage logic of a computer chip safely and reliably command the raw, brute force power of industrial machinery.
So you see, they're doing more than just flipping a switch. They're the reliable muscle, designed to keep on working even if the power grid gets a little shaky. That reliability secures uptime and prevents really expensive shutdowns. Ultimately, contactors are what make it possible to automate entire industries, from digging resources out of the ground to shipping a finished product out the door.
Which kind of leaves us with a fascinating question to chew on. The contactor has been a pillar of industrial control for more than 100 years. But as we push forward into a world of smarter factories, electric vehicles, and massive renewable energy grids, what new challenges, what new jobs are we going to ask of these powerful hidden switches?
Let's study more and like, share, and subscribe for such more content, and comment something you want to learn.